Okay, so now we go to the next part of the experiment. We have already created a LED and connected it to the supply. So now let's see how to place a, you have to click on the component, place a battery. So you have to type DC, or you can also type BATT battery, and you will get the active battery. Always try to choose a library which is active and then click OK. And then you can place a battery. Typical battery is of 12 volt. Let's say you want to change it to a cell of 1.5 volt. You have to double click on this and change the voltage to 1. Let's say 5 volt. Now I want to solve a simple BEE problem. Like I have a resistor network. So let me go to place component again. Uh, and let's place resistors. So I would choose, let's say, 1 kilo ohm resistor. Now we will try to evaluate Ohm's law. So if I connect a 1 kilo ohm resistor and I want to find the current flowing through resistor, so I will go to the so below the generator there is a probe mode, and then there is something called as devices, where you will see oscilloscope, logic analyzer, counter with timers, virtual terminals, SPI debugger, I2C debugger, signal generator, pattern generator, and then there is DC voltmeter, then DC ammeter. So I will take DC ammeter from that, put here and connect them in series with the resistor. Okay, so ideally the current flowing should be 1.5 volt upon 1K. Similarly, I want to measure a voltage, so I will choose a DC voltmeter. I will place that also here, and I will connect it to the circuit so that I can measure the voltage, and we will try to see whether Ohm's law is correct or not, or is it being followed in the Proteus or not. And then typically don't miss to place the ground. It is not needed because ground is a reference terminal, but it is always better to place a ground to the negative terminal of the battery and then run the simulation. Okay, so you got 1.5 volt correctly, but you will see the current is still zero. Now, the reason for this being the range. So your current meter typically comes with the range. You have to double click on that. Okay, and here you will get a display range. So my current will be maybe in milliamps or microamps. So you can choose a suitable range here and click OK again, and then try to run the simulation. So now it is showing 1.5 milliamps. So which is correct. So 1.5 volt, 1K current should be 1.5 milliamps. Now this is the example where we place a DC circuit. Now let's go to the complicated AC signals. So I will just delete this DC source. Again, I will go to the input, and here I want to place a signal generator, let's say. So there are two ways to place a AC source. Either you go to the source part and then you choose a sine wave source, or you go to the instruments part and choose something called as signal generator. So I am putting a signal generator here. You can do anything. So right now I will go to the source because that is the easier one, and I will from the source I will choose a sinusoid, and I will place that sine wave to the resistor. Okay. Now double click on this. You can see there are all the options, what kind of source type you want. There are digital options here, and then there is offset value, there is amplitude, and there is frequency. So I would set my amplitude to again 1.5 volt, but now it's a AC, and frequency is 1 hertz. so that we can see, or even you can reduce it to 0.5 hertz and click OK. So now if you run, you should see that these values are continuously changing, and this is not the good way to see any result with respect to AC. The next thing I'm going to show you is how to put the oscilloscope. Go to instrument again. Now this oscilloscope is nothing but a CRO. Uh, Typically 4-channel CRO is available with the Proteus software. So you can choose any one channel and try to connect it, and then again run. So you will see that nothing is appearing on the CRO. Reason being, you are not measuring the correct volts per division. So channel 1, you can change the volts per division and try to see if any signal is there or not. And on the same time, you have to change your time per division knob also, which is here. And it is very difficult to find 0.5 hertz signal, whether this yellow line is changing or not. So what I would suggest is to increase the frequency, and then we will see. Anyways, this milliampere ammeter is not of use anymore. So what I will do is stop the simulation. I will delete this. Okay. Then I will choose CRO again, oscilloscope. Okay. First I will check the input. Okay. Then let me have one more resistor. Now if you want to rotate a part, you right click on it. Okay. And there is a rotate option. So I have rotated the resistor. If you want to delete the earlier wire, what you can do is click on this selection mode, then click on this thing and then press delete. Again same way, select, delete. I want my ground, so just do this, and now I will connect this voltage division point to channel B. So now here you can see you should get full voltage, which is your, let's say, 5 volt, and frequency, let's say 100 hertz or 1001 kilohertz, and click OK. And now you can press run. So as soon as you close the CRO option, the simulation will not open that window again for you. So you have to be very careful when you close the CRO button. Now, only way back is you have to recreate the entire simulation. Now, since you cannot save it, there is no option that you can do anything. So I will recreate it because I have closed the CRO button, and now I can just take a new project. No, I don't want to save projects. Go next, 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 finish. It's on. Go to the place. Now I can go to register. I guess 1K is what we chose. Place 1, place 2nd, right click, rotate. Then go to generator, get the sine wave source, place it. Then go to the ground, select ground, place it. Then do the connections. So if you want to specifically bend from here, you can click here, then click here, and then click here. You can do that way also, so that you get the specific bends wherever you want. Then I will go to oscilloscope. I will place my oscilloscope. Hopefully this time it will work. Otherwise, I have last option of closing down the Proteus and restarting. So now I'll run this. Okay. So don't close the CRO. That is the only thing. You can stop, then double click on this. Its amplitude 1 volt. Let's change it to 5 volts. Frequency 1000. Click OK. And now rerun. So what does voltage division law says? If you have two resistors of same value, then voltage gets equally divided. So voltage at channel B should be half the voltage of channel A, and that is what we are going to see now. So here both the voltage divisions are at 5 volts. Now let me change it to 2 volts for blue channel and 2 volts for yellow channel. And now you can measure the divisions. If you want to move your waveform up down, you can do it using this. So this is where you can move the trace. So if you align them properly, you will see that blue wave is exactly half the yellow wave. Even you can move your blue wave. So this is currently only 2 channels. If you want to see in detail, you can do this time domain shift. Okay. And then you can see if you match it perfectly, you can verify the voltage division law. Okay. So this was about the oscilloscope, AC, DC ammeter. Similarly, you have wattmeter also, and then pattern generator is also there. Then in components, how to place ICs. There are multiple ICs. We are going to see them. There is 1555 timer IC, which will be very prominently used. Then 741 op-amp IC is there. Then 740, I guess 7402, whichever component you want. It's an AND gate. So in the morning's lecture, we saw about gates. So that is your second experiment, basic gates implementation. So there you can use 74 series, 7402, 7404 NOT gate and so on. And then it is very easy to place them also. While simulation is running, you cannot do anything. So you have to stop and then only you can run the simulations. So our next task, I will stop the recording now.